Okay, this is what we did last time. So the concept of virtual function. Different object-oriented language has a different implementation of so-called polymorphism. And even for virtual function, different programming languages implements somewhat differently. So this is quite unique. This is a language specific. Java also have a virtual function, but in Java, the virtual function is default, and it's very different the way they specify. So, so just be careful. This is specific to C++. That's point number one. So what is a virtual function is in C++, of course, is actually how do I say that? Realization of polymorphism. So what is a polymorphism? The definition of polymorphism is that for the same object, when you try to hit it with a particular function signature, which you're expecting to match a particular function instance that you want the object to respond. So polymorphism means that when you hit it with exactly the same member function signature, the function might behave differently. It has polymorphic behavior. So that's why it's called polymorphism. I mean, it has its purpose, but it introduces some complexity you need to manage for your whole software program you try to develop. It's a powerful concept, and we will show you how you can use that in homework assignment number 3. But just be careful, any programming language, linguistics, syntax they provide, we learn syntax, but we need to learn how to use it appropriately. Otherwise, there will be bugs and other things. So this slide kind of summarizes the C++ version of virtual function. So the contrast between the regular function, non-virtual function, and the virtual function is that the function instance that you try to invoke is actually determined at runtime instead of compiler time. So the thing is that regular function, the particular member function is determined based on the data type. At the time the function was called. So because of this property, that the compiler can know that, because compiler will know exactly where and when this line of code is called. So compiler will gather the information at that point, and then the compiler can bind it. So essentially, this is a static binding at the compiler time. So that's a regular function. That's pretty much all the code we have written up to this point. But virtual function is different. The virtual function really needs some information at the time that object instance was created. So essentially, compilers don't know your code, to be honest, and don't know which function or which lines of code is create a particular object that we're talking about at this moment. So essentially, compiler doesn't have the information. We rely on runtime information to determine dynamic. Sometimes it's a virtual function is almost like a dynamic binding. It's not a compiler time property. Therefore, it's how do I say that? It's both that because you don't know that, so you could get some interesting surprise when you make that function call if it's a virtual function. Okay. All right. So that's the summarization about the contrast. I mean, the important thing I want you to know is not only how to specify virtual function, but probably more important, you need to learn this concept is that this is runtime, dynamic binding, instead of the compiler time, that statically you can link the code to that. And therefore, because you cannot statically link the code, you have to use concepts such as function pointer, means a pointer to a function that allow you to dynamically set that pointer value so you can reference that pointer to actually call a real function that the program is supposed to call based on this information. Okay. Any question? Okay, so knowing this, that we show, oh, okay, I want to go back to one slide. Now, this is actually a good, very good slide for you to understand the difference between a regular function. This is how a regular function, you can write the program like this to call the function called foo. This is the regular function. When you do casting the object, it will change that behavior to whatever it changed to. But casting will not impact virtual function. I mean, no matter how you cast, I will still remember what object, what class you actually create this object. So it will always, regardless how you casting the object, it will always go back to the virtual function. That's one of the properties. There's a few properties about virtual function you should be aware of before you really use it. Sorry, hold on 1 second. And based on this concept, we actually utilize this in homework assignment number 3 to come up with using virtual functions, but expand our class hierarchy or inheritance hierarchy to from transaction to fly, which we already talked about a little bit last time, but we extended to Shadowfly. And they actually have a virtual function called get distance. So get distance is your homework assignment number 2. I kind of moved that get distance to a subclass called fly. I mean, homework 2, you just deal with generic transaction. You use the class transaction to do fly. But now homework 3, we make it more explicit. We kind of refine that class hierarchy and move that. By the way, this is very common in object-oriented programming, that initially we didn't define the class exactly what we want. And then we actually try to, after we know the concept a little bit better, we start to change the code, we move it out such that the parent class becomes more generic, and we subclass to make it more specialized for the purpose, such as a concept transaction. So in other words, I can have a transaction for fly, transaction for go to target, or transaction for doing some other activity. So you can actually gradually specify and you move the member function, some of that, out of the parent class. But here is something interesting, is that not only we split the fly out of transaction, but we actually introduce a new concept called Shadowfly. And the reason we have a Shadowfly is that we actually utilize the virtual function, which I'm going to explain to you. So we're going to spend, I'm going to spend a lot of time, start to working on homework assignment number 3 with you. And today, the discussion hour, I'm going to talk about a demonstration and detail about how to do homework assignment number 3, just let you know today, this afternoon. But the concept in homework 3, in fact, homework 3, maybe we have a little bit, but not too much, is a concept called shadow object. So what is a shadow object? I mentioned this concept already. Let me just quickly recap what I talked about last week. What we want is virtually all the object I'm dealing with is actually locally on my phone. In fact, I'm actually developing some program that you can imagine that this is my phone. I'm running my C++ application, but all my object, the real object doing the real work, is on one of the Raspberry Pi device. So you probably heard about Raspberry Pi. It's a very inexpensive, but now getting really powerful computer. I mean, the last time I checked, Raspberry Pi 4, its power is way beyond the top of the line, maybe 10, 15 years ago, or maybe 20 years ago when I used the same processor to do things. It's really powerful, but it can actually do a lot of sensing for air quality, for surveillance, for a lot of other things. So I'm actually interacting with, say, on this campus, we have just a hypothetical number. We have about 10,000 Raspberry Pi. It's actually interacting with community member at every single point on this campus. And they actually create a lot of objects for transaction, for person, for whatever, assuming we don't worry about privacy at this moment, okay? And so what I want to do is I want to do some kind of remote interaction with all this object. And you can imagine that sometimes it might be difficult because, well, I have to know where the Raspberry Pi is. I have to know which Raspberry Pi I want to interact with what. So sometimes you need to keep tracking this all the time. It might be easier for you to configure in a way that you only worry about this once. Once you finish worry about this, and from now on, you just interact the shadow of that particular object you're interested on your phone. So it's as if you are actually interact. You develop your program with those shadows, regardless where they are, regardless whether they're a Raspberry Pi, maybe those things are on your computer. It's just totally wrapped around such that you don't have to worry about this thing. This is called shadow object. So let me define what shadow object is. Shadow object is a representation of a real object for you and your application. When I say you, I'm really talking about your application, that your application will interact directly with shadow such that it doesn't even need to know what is the real. It hides all this detail about, such as its location, its IP address, and things like that. So that's the idea of a shadow object. So essentially what we want to draw is this is a simple picture with only one shadow object. So you have the real object you want to deal with is on a different location. But my application is written regardless where they are. And such that I create a shadow locally on my computer. So as if I'm actually only interact with my local object. But all my requests, such as member function call, it will be redirect to the real one. Okay, and that's the basic concept of shadow object. You have a question? Okay. All right. So, by the way, if you can do this, you actually start to be able to see distributed programming. When you do this, distributed programming is usually we do not emphasize a lot in the first course. In fact, we don't say anything. But when you look at more large program, just like an ecs36b, you will see that in real world, it's really about distributed programming today because the internet, the connectivity we have, is a lot of real application that you're using. It's pretty much, it's harder this day to find an application that doesn't need any internet connection, in fact. So I'm actually going to talk about what will enable us to be able to realize the concept of shadow object. And I want to introduce a concept. Let me see. This is I can this. This is a concept that we want you to be familiar with for homework assignment number 3. It's called remote procedure call. By the way, I also want to tell you that I have been start thinking about what is the final project that I want you to work on, which I will probably spend maybe next discussion, not today, the next discussion to talk about that in depth. And when I'm just pondering about the possibility, I'm actually thinking whether I can start kind of give you some idea that you can develop something that you can run very nicely, that people can use it on this campus. So I will tell you a lot more about that. And some of that actually you probably all have to use either shadow object or remote procedure call. Okay, so what is a remote procedure call? So a typical function call, do I have that? Yeah, okay. So this is the difference between a regular function call and a remote procedure call. So a regular function call, if you call that function foo, I mean, they must be in the same program. Either you in the same file, something .c or .cpp file, or it's actually belong to 2 different files, and you do separate compilation, but you link them together in the same makefile rule. And then this is a single program. Both the caller and the calling are both in the same executable. So that's a traditional procedure call. You're calling a procedure, everything is there. But remote procedure call try to break the code into multiple parts. So essentially, I'm actually making my caller in one program, and my calling is actually in another program. So you're actually running like a client server. In fact, this is actually a server. This is a client. So when client issue a call, that call will be transferred to the other program, and the other program will direct that to this piece of function. So what really happened is that the remote procedure call enable you to, when you make the call, it recognizes this is actually remote. This is not local. That's number one, it has to realize. If it's a remote, it will find the network connection to the target. And the target, when they receive it as a server, it will check which function in this space you try to invoke. So there is a communication protocol for you to decide whether that call was made by the program on the left is indeed supported by this local, the server, the double. If that happens, then the whole call will be successful, and whatever result, you see this one is return a pointer to double, and that's interesting because what does pointer mean? So usually this is actually flawed because it should be only double, not double star, because double star, the pointer, I don't know how the one thing about remote procedure call, these are 2 different machines, there are 2 different memory space. So the memory address doesn't make sense unless this one wants to manage the memory in this machine. Okay, that's the only possibility. But anyway, whatever result you got, it will return to the caller, and the caller will get the result. Just like as if it is made a regular procedure call. So this is called RPC. Yes. Right. Yes, it's calling from separate machine, or it could be calling 2 different processes or two different what we call tasks on the same machine. That's also possible. Right. Okay. You're asking about the memory address in this case. Is that right? Yeah. So I think that only makes sense if I have other remote procedure call, which is also use that address on the server side. On the same. That's the only thing. So you return me a double. And I could potentially use a double star, which is a 64-bit integer, and use that as a parameter, another remote procedure call on the same memory map. What? Right, for multiple. And that's actually useful. Yeah, but it's kind of, I don't feel comfortable. It's a safety, it's a security issue. I'm actually letting a virus program to remote procedure call to my memory space. That's actually kind of. Yeah. Any other question? So just the concept, remote procedure call. So we're going to tell you how you can do that. So as you can see that there need to be some kind of interface to define the information exchange from the server and the client between those two. So we have to do something to actually specify that. So the interface for enable remote procedure call. By the way, RPC was first developed by Sun Microsystems. The first version is probably somewhere 1989 or 1988. That was the first time remote procedure call. The concept being introduced and realized that was Sun Microsystems, and Sun Microsystems now is a part of Oracle. And at that time, they used a specification language called XDR. XDR, I think, is for I forgot what it is. XDR used to be able to pronounce all the abbreviation in computer science. By the way, this is the greatest contribution, in my opinion, for the computer scientists or IT. We introduced so many abbreviations that we cannot remember all of them. Okay, so you have to do Google to represent. External data representation, XDR. Actually, I remind myself with Wikipedia link. So XDR stands for external data representation. Is how, by the name, you know how it actually led this two sides to be able to do that. So the newer version of XDR, now people no longer use the original version of XDR, that we're using JSON. So essentially we're using JSON, JavaScript object notation, to represent the information that XDR used to represent. So I'll show you some example a bit later. But essentially what you did is that you using a JSON. So now I'm actually telling you when I wrote my first RPC program using XDR, of course, I'm using a tool called RPC Gen. So essentially what it does is it takes the XDR specification about the remote procedure call. It's a code generator. It will generate two pieces of code. One piece of code is actually going to the client side. So that's why you say you will include the client.h. Here is include server.h. Those code are basically being generated by that XDR compiler. And the thing is that right now we're using a similar program. It's called Json Rpc stub. So this is your homework assignment number 3. You will be doing this. Is that you use JSON to represent the communication between client and server, and then you use a program which, if you're using CSIF, this program is already installed. if you're not using CSI on your machine, I actually provide an instruction how you can install Json Rpc, Json Rpc CPP or Json CPP Rpc, I forgot. It basically help you to be able to generate that. So you will actually generate 2 pieces of code using the Json Rpc stuff. All right. Any question? You haven't seen my demo, so maybe this afternoon I will show you demo about how this will work. Okay. So I'm going to show you an example about what the Json Rpc looks like. Wait a minute, where is my? Oh, I lost it. Okay, that's fine. Let me actually just show you this picture so you actually know what's going on. So this is a lot of code that's actually involved in homework assignment number 3. But the code that actually we need to start it is this code called ecs36b underscore homework 3.json. That this piece of code is what I call the representation XDR. And this code will generate hw3 server.h, hw3 server client.h, those two .h files, because it specifies the protocol. And those two will be included in 2 other programs you will develop, which is hw3 server.cpp and hw3 client.cpp. So I'm going to show you how this program looks like right now. Okay, so this is a JSON file represent the call. So we define 4 different functions. Just to let you know, I define 4 different functions, but except the last one called web report. I will talk about web report a little bit later. So those are the 4 functions. The first one is get distance. The second function, this is all JSON. The second function is called conflict of interest. The third function is called operator equal. Basically is a overloading, but it's overloading on a remote computer. Okay, it's operator equal. And then the fourth function is called get VSID. So there are 4 functions that I like to define between the client server and the homework assignment number 3. So let's actually take a look at each of them. I just show you one, and then hopefully you will get the idea. So essentially, I define 2 things in this remote procedure call. Number 1 is what parameter I need to pass to the other side, and what is the return that I expect to get from the other side. So for the parameter, when I want to send over there, I actually send 1, 2, 3, 4, 5, 6. I actually send 6 parameters. I define 6 parameters. The first parameter is called action. The second parameter is called owner VSID. The third parameter, host URL. The fourth, class ID, object ID. The final one, I just call the arguments. In fact, arguments is itself JSON. if I define it here. I pretty much want to show you that in this RPC, the right-hand side of this column is actually irrelevant. Means that they're not actually being used. The only thing that matters is this parameter name here. What do you have over here? So essentially what we want to do is that when you make a call, you make sure that your call has those 6 arguments. That actually when you make a call, when you see let me actually show you the demo so you can probably see what it looks like. So this is a client.cpp. Do I have get this? Okay, this one is good. You see that I have equal, this is operator overloading. Operator equal. So this, I'm just doing a simple comparison or doing whatever those function. But you won't actually see those things until you, give me a second, let me pull out my shadow.person. I hope this is the complete code. Okay, I think so. You see that this is operator equal. When inside the operator equal, that when you wrote the program, let me actually make this a little bit smaller so you can see the whole thing nicely. Yeah, okay. Okay, this is actually defined under a shadow object called shadow person that it has an operator equal. So usually, let me actually compare this with a regular person's operator equal. Okay, so this is the regular person's operator equal. And you can see that I'm just basically compare the VSID the same, the name the same. If they're both the same, I actually consider I return the equal. So that is the real version that I would like to call. But now I'm actually calling a shadow person. So the real person may be Australia, but I want to pretend that person is local in Davis. I have a shadow of that person in Australia at the moment. So I'm actually going to call operator equal to that local instance. Of course, that local instance is not going to have information to do this line. It doesn't have the SS or all the information. Instead, what I did is I wrote this few lines of wrapper. Let me actually make it bigger so you can see the whole thing. So essentially, I actually need to configure. Of course, I have to configure for the client and for the, by the way, this is using host URL for me to understand that. And then to define the client as a Json Rpc client. I mean, this few line, this 1, 2, 3 line is pretty much everything. You have to have that in the Json Rpc programming. But the most important thing is this line. This is a real you're going to call. You see that? That's how I call. I said my client.operation equal. Now you see that I'm not using that to equal sign. I'm using eq. That's how I define in the ecs36b underscore h3 hw3.json. That's a file. And then remember I said there are 6 parameters. And you can see here you have a 1, 2, 3, 4. Oh, there's more than 6. Let me actually check. How many parameters I have? 1, 2, 3. Now the first one is class ID, your host ID, object ID, owner VS ID, and then the action, description. Oh, yeah. No, I have 10. Because operator equal took 2 parameters, not just 1 parameter. Let me actually show you what it looks like. Because I show you this is a get distance. Get distance has 6. But if you go to operator equal, it has 10. Because it has 4. The action is whatever the call operator equal. This is the action. And then there is a 1, 2, 3, 4 is a 1 pair because you're comparing 2 objects. And then you have a person and another 4, and then you have some kind of argument that you put in there. So there are 10. Depending on how you specify in that JSON specification file, and that's actually how you're going to match with this. You can see that the order of the argument is somewhat different. The reason the order of the argument is different is that the RP, I actually specify in that order on the top, but the RPC stub, they actually compile the code and generate the client. That's actually following this order. That's why in order for me to call that program successfully, I have to use that. Let me actually show you the program that was generated. It's a bit extended, but hopefully you get some feeling. It should be in client.h. That's my guess. Where's my client.h? I lost that? Wait a minute. Let me just make it again. Sorry, this must be something is wrong. Let me hold on. That's embarrassing. I want to do, okay, I want to make, okay, so you can see that I actually make HW3 client.h. You can see that this make rule, it called Json Rpc stub. Based on this, and based on this is actually generate that. So let's take a look at the code. Now I have HW3 client.h. Let's actually take a look at this code. So essentially what it does, let's take a look at this. You don't have to write this code. It's actually generated, but you're going to use this code. You can see that it generates a code called operator equal, and it actually generates the type and the name for all this 10 different attributes based on the JSON file, ecs36b homework 3 they provide. And inside there, all they did is just encoded everything you pass into this file, encoded to be itself a JSON. So by the way, here you see that we're start doing JSON programming. This is C++, but the C++ library to handle JSON. And they actually create an object P called JSON value, and it is encoded all the 10 arguments using the JSON encoding. So instead of for you to manually type in the JSON, you can actually just use the JSON CPP library to encode this very easily. And after you've done all this, after you encode all this JSON, you just simply call this method. This is actually the real remote procedure call. So you basically call a method, and then you just basically provide the name of the method called operator equal, and then provide that P. The P is essentially the wraparound of everything that you actually just provided. And then that will be actually sent to the remote for the remote server to handle. Of course, we can take a look at what is the remote. HW3 server .h. This is actually the remote part is also generated. And HW3 server, you can actually see that it has all the method being binded. One of the method being binded, is here. This is exactly the same code that will match with what you got from the other side. Also, those 10 parameter, but those 10 parameter are all encoded into the JSON. And later, if you've done this, let me actually just show you what it will get down to. Oh, wait a minute. I just. And here, eventually, this is the call. It's going to be made on the server side. It basically has operator equal equal. It actually, you see now, is actually converted back from the JSON to the regular data type that exactly match the other side. And inside here, you're going to start to write your code. So that's actually complete the whole thing. From the client to the server, and then you basically do that. So let me, this is not exactly the call. The call is actually here. I want to show you where it is. Hold on 1 second. Here. You see that here, this one? Person compared to person. P is a person. So I dereference a pointer compared to equal equal. This equal equal, by the way, is override, is operator overloading on the server side. So this time I'm really calling the operator equal equal in the person.cpp instead of shadow person.cpp. Okay, so now let me actually go back to this slide. I just, sorry, this the first time you saw this, you got so confused, but I will go over this concept again. But now I actually can talk about this slide. So what we have is that we have this specification within JSON to say how a client server should interact. It actually generates HW3H and HW3 server, so it will be able to provide the code template for you to use to actually make the whole thing work correctly. So what it does is that when you first make a call to one of the functions, say JSON dot sorry, that operator equal equal. Sorry, I forgot to put shadow underscore person. The shadow underscore .h is the same. So essentially, you're going to call the shadow person version of that call, operator equal equal. And that will be delivered by the client and then to the server. And the server, when they receive it, they recognize everything correctly. It will actually call the real version in person.cpp, the operator equal equal. So it's just one function. That's why I have to do 4 functions, but you see the flow about any one of the function is basically follow the same protocol within this complicated picture. Okay, any question? So right now I didn't show you a lot of code. I expect this afternoon I'm actually going through slower, but based on based on the line of code and then the real action about the code. Okay, any question? All right, that will be it for this lecture. As usual, I will stay here. If you have any question, please just let me turn off. Then I talk to you. Okay, give me 1 second.